Right, let's see how to add multiple vectors. Let's say we have one vector here, another vector here. Let's call them v1, and so on. We have another vector here, another vector here, another vector here. So one thing you could do is simply, to shift. Start by shifting vector 2 towards vector 1. So you would have the following. Then you would put them, let's say, head to tail, so that the head of vector 1 coincides with the tail of vector 2, and then you can draw this vector here, which will be the sum of the two. Let's call this vector v1, 2. So v1, 2 will be equal to v1 plus v2. Okay, that's something quite straightforward. But what we can do, of course, you could take v1, 2, add the third vector, add it to the third vector, and so on. There's something much faster you can do, and that's the following. What you can do, you can position the vectors the following way. I'm just drawing them again here. We have v1. I'm just shifting v2. I'm moving it in space, something that you're allowed to do with vectors. I'm not changing its magnitude or direction. Then we'll have v2. This will be v3. This will be v4. Then we have the last vector here, which we call v5. Then from here, what I can do is the following. So if it's not really clear, let me just, okay, this will be v3, this will be v4, and this is v5. Now, these are the same 5 vectors. So what you can do is to simply draw a line between the tail of the first vector and the head of the last vector, like this. Let's call this S. So what we can say is that S is equal to v1 plus v2 plus v3 plus v4 plus v5. As you can see, this method is much faster than adding one vector at a time. So if you have vector difference, you can do the same. Just remember that a subtraction or difference will be the same as multiplying your vector by -1. So you would just flip the vector, but you would use exactly the same method.